Hey, welcome back. We talked about atomic mass and about atomic number, and now we're going to look at why this number down here at the bottom is a decimal and not a whole number. We learned before that atomic mass is equal to protons plus neutrons. So we know that if it's a mass of 16, I look here and see the atomic number, and the atomic number is 8, which is the number of protons. To solve for the number of neutrons, I just add it together. So 8 plus 8 is 16. And that is what we had covered before. If 8 plus 8 equals 16, why is the mass 15.99 and not 16? Why do we have to round up to get the 16? The reason why this number is a decimal place is because of isotopes. Every element is going to have an isotope for the most part. Isotopes contain different numbers of neutrons. This causes them to have different masses. So it's the exact same element, it just has a different mass. The only thing that changed is the number of neutrons, which then changes the mass. The protons will never change because that is what makes the element what it is. If it's 8, it's oxygen. If it's 7, it's not oxygen. If it's 9, it's not oxygen. Protons are the identity of the element. The number of neutrons can change. So usually we will call them by their mass. So oxygen 16 is written like this with the hyphen, and then the 16 is the mass. Another way that you can write it with symbols is like this. Notice the atomic number is on the bottom, number of protons, and the mass is on the top. You could also have oxygen 17. This is telling you that the mass is 17, but notice again, the 8 at the bottom stays the same because we're still talking about oxygen. You can also have oxygen 18, whose mass is 18, but once again, the number of protons is still 8. These are the 3 naturally occurring isotopes of oxygen. We cannot just say that oxygen is 16 because although the percentages may be small, these other oxygens do exist and can occur in compounds, so we must take them into account. How often these isotopes occur is given to us numerically by relative abundance. It is written as a percentage and gives you an idea of the chance out of 100 atoms that these compounds would occur. So 99.757% is going to represent the percent abundance for oxygen, meaning most of the oxygens you encounter would be oxygen 16. But 0.038% will be oxygen 17, and 0.205% will be oxygen 18. Now you can see why the number turned out to be 15.99, because so much of the actual oxygen is oxygen 16. So how do I go about calculating the average atomic mass if I have all these different numbers? I can't just add them up together and divide by 3 because that would be assuming equal percentages. So I will take their calculated masses. So oxygen 16 has a calculated mass of 15.99. I will multiply it times their percent abundance. So this right here will represent oxygen 16. Then I will add the next isotope. Oxygen 17 has a calculated mass of 0.99. These are numbers that will be given to you. And a relative abundance of 0.038%, which I can write mathematically as 0.00038. This will represent my oxygen 17. And then I have one more isotope to represent, and its calculated mass will be 17.99, and its relative abundance will be 0.00205. And then I will show you this is oxygen 18's number. So I'll multiply first, and then I will add them together. And that number will be the average atomic mass of oxygen. And that is why the number is 15.99. See you next time. Bye-bye.